going to be importing this data into Excel so that we can make sense of it, including determining whether there is a bias between the carbon dioxide detector 1 and the carbon dioxide detector 2, which was side by side with it, determining what the relative percent difference is between them on average, and then charting it by time. So I'm going to be following the instructions in this Word document as we go through and import this data. The first thing you do after you've got Excel open is go to the Data tab, then Import from Text in the Get External Data chunk. Click that and then navigate to the co2.txt file. Select it, say Import. Then if you want to preview the data, this Text Import Wizard first panel shows you the first few rows of data so that you can see what these various options look like if you select them with your data. We know that our file is tab delimited because if you take a look at it, you can see that there are no commas that separate these columns. The data does look a little weird because we've got the headers offset from the data columns, but it's definitely tab delimited. We want to start the import at row 2 just to be consistent, and then we can refer to cells and columns. We say Next. Now we have to tell Excel what the delimiter is. In some cases there's more than one delimiter. In this case they are tabs, so I am just going to leave the tab box checked. If you want to select different delimiters, you can. For example, let's take a look at what the semicolon delimiter tab looks like with our data. And you can see that it doesn't delimit the data at all. It's all run together into one giant column. If we click Tab and then use this grabber bar on the right to pull through our data, we can see that it has separated the data properly. The first column has something to do with time, even though it's in a format that doesn't make too much sense in terms of time yet. And the second and third columns are parts per million, and that looks good. They're in the 500 range, which is the average for indoor carbon dioxide levels. So we're going to leave the tab box checked and then click Next. And now if we have any fields that we're importing that have anything to do with date or time, I recommend checking the date, and sometimes this can make a difference and sometimes not, but it's better to be safe than sorry. So we're going to leave this month, day, year, even though we know it's only time. And you can see that there are different options for the formatting of date, time columns, year, month, date, etc. But we're just going to leave it at month, day, year for now, but call it date. And then the second column and the third column we're going to leave as general because those are numbers, and general is fine for understanding that. Then we're going to say Finish. Then Excel gives you the option of where you want to put that in your sheet. You could leave it as the default, but to be consistent with the directions so we can refer to cell identifiers, I'm going to put it in A2. And to get there, you could either just type in equals A2 here, or you can click on this multicolor box, which minimizes this dialog box, thereby allowing you to click in the sheet what you want to be put in the box, and you can see it now identifies that cell where you want to put the beginning of the data into as cell A2 on sheet 1. So we're going to click this multicolor box again so that we can now click OK, and then it imports the data, and now you have it. If you haven't already done it, it's time to make an entry in your database logbook and note what you've done, if this is your real data. So one of the very important things in Excel is that you always want to minimize any blank rows or columns. So I'm going to click on the entire row 7 here because I see the row is blank. So I click on the 7 and that selects the entire row. Then I go to the Home tab and I click on Delete. So we want to delete that whole row, which it did. So now we're going to go on to the next step. So we want our headers to make sense. So this is our header row here, row 6. You can see the first header says hour, which it doesn't look like these are hours, but we'll worry about that later. And we've got two detectors here. We've got carbon dioxide detector 1 reading out in ppm and carbon dioxide detector 2 reading out in ppm. I want the headers to be unique, so I'm going to change this to ppm 1, and then I'm going to change this one to ppm 2. That way we have a row of headers and each one is different, which is important as we'll see later. The next step is to add a column that shows the average of carbon dioxide detector 1 and carbon dioxide detector 2. So I'm going to first type in a header, and I'm just going to call it average in this case. And then I want Excel to calculate the average of this value and this value. So there are several ways of doing this. The easiest way for me is type in an equal sign, and then Excel knows that this is going to be an equation. And once you type in an equal sign, you can see that the formula bar appears up here. One way of doing it here is to click on the different functions, including average. So just showing you how that one works, I'm going to click average, and this appears only after you've typed an equal sign in the cell. So Excel knows, oh, she wants to add a formula, so we'll show her commonly used formulas here. So I'm going to select average, and then it gives you this dialog box. And it makes a suggestion. Do you want to average everything here, A7 through C7? Actually, no, that's not what we want. So I'm going to follow the prompts in the dialog box, and I'm going to say I want it to calculate the average of what's in column B and the average of what's in column C. So the first one is column B. So I'm going to click on this little multicolored square, which then allows me to click here as the first argument, Excel calls these, and then the second thing I wanted to average is what's in column C. So I'm going to click on this multicolored box, and then I'm going to click in column C, and now you see it shows up here the average of what's in B7 and C7, and that's exactly what I want. So I'm going to click on this multicolored box again, and I don't want it to add more numbers. I don't want it to average in that 0 for hour, because that wouldn't make sense. So I'm going to click OK. So now you can see it gives me the value of about 520, which looks to be the average of between 541 and 498. That sounds about right. The next thing we want to do is add a column for the difference between carbon dioxide 1 and carbon dioxide 2. So I'm just going to type in a header here called diff for difference. Click enter, and now I'm going to type in an equation. So first I type in the equal sign, but I'm just going to go ahead and tell Excel what I want rather than using the dialog box. So I want the difference between what's in the two columns. So I'm going to click equals, and I could either type in B7, and you see what's so great about Excel is it gives me the cell that I'm telling it to put into the equation in color. Then I'm going to click the minus sign, which is to the right of the 0 in your numbers on your keyboard, minus, and now I'm going to say C7, and you can type in lowercase, it doesn't matter, C7, and then it puts that cell in green along with the C7 in green, so it's a way of visualizing the equation. And now I hit enter, and now that tells me the difference is 43 parts per million, which looks about right, because that's 542 minus 498. 43 sounds good. Now I want to add a column called absolute value of the difference. So I'm just going to type in a header, and I'm going to put in abs_val and then hit enter, and now I'm going to click the equal sign again so Excel knows this is an equation, and I'm going to just type in A, B, and you can see that once you click an equal sign and then you start typing, Excel gives you a list of possible functions that begin with that letter. So I could be picking any one of these other things, but I'm picking absolute value. So the absolute value of what? I'm going to click open parentheses, and now Excel gives us hints. It says, okay, what you need to type in next, Melinda, is the number. So I want the absolute value of this difference, because sometimes this difference is going to be positive, sometimes this difference is going to be negative. So I'm going to click in that cell now, and you can see that it put E7 into the function as the argument. So now I'm going to click the right parentheses and click enter. And now I've got that column set up, at least in the first row. Now the last column I want to enter is the relative percent difference, because what we're going to be assuming is that these two carbon dioxide detectors are not exactly identical. One of them we think is more reliable than the other, and we want to see if there's an overall trend between them. And this would be the same kind of thing that you would do if you were looking at two different monitors, or even two monitors at different locations if you wanted to see the difference between them. So I'm going to just type in RPD for relative percent difference as the header and click enter, and now I'm going to click equals, and now I'm going to enter what I want Excel to calculate. The relative percent difference in this case, because we're not exactly sure which one of these carbon dioxide detectors is better than the other, remember that when you're calculating relative percent difference, you're taking a proportion of what you think is the best value. Well, in this case, the best value is the average of the two. So I'm going to type in equals, and then I'm going to click on E7, because that's the difference between the two carbon dioxide detectors, divided by, which in Excel is the slash key, the average. So then I'm going to click in D7, and then that fills in D7 in my equation, and you can see it's green, which helps you identify which column it's talking about. I click enter, and now you can see it gives me a value of 0.08. Well, this is not in a percentage yet. We will apply that format in a bit, but basically this is 8%. So for this value, so at this time when these measurements started, these two carbon dioxide detectors were 8% different. Now we want to copy these equations so that they include all of the data that we have. One way of doing it is to just copy what's in here down all of these cells. That would take a long time. What we can do is we can copy all of these equations at once by selecting the columns that have the equations we want to copy. And then with these selected, you hover your cursor over the little tiny box in the lower right hand corner of the selection. And when you put your cursor there, it turns into a thin black cross. With the thin black cross showing, you double click, ta-da! It copies the equations all the way down, and it will copy them all the way to the bottom of your data as long as you don't have any blanks in this column here to the left of the data that you're copying down into. And you can see that we have a lot of data. It would take a long time. If you scroll down, you can see how much data we have. One way of looking at all your data at once without laboriously pulling this grabber bar down on the right and going down, down, down thousands of rows is you can click anywhere in your data, and this works again as long as there aren't blank cells. If you hold down your control key on your keyboard and then the down arrow, it'll zoom down to the last cell where there's data and stop before the blank cell. So you can see that if you've got blanks, this zooming won't work. So we've got 8,497 rows of data minus the headers at the top. I'm going to zoom back up by holding down the control key and clicking the up arrow, and that takes me all the way up to the top of the set of data, stopping at the last filled cell.